Okay, let's take a look at question 2. There's also definitely a few things I want to explain. Okay, so the data in the table shows the number of passengers and the number of suitcases on various airplanes. Now, it should probably make sense that the number of suitcases depends on the number of passengers. So suitcases is dependent and it's on the y, and passengers is independent and it's on the x. So you plug in all your numbers and we get these dots. If you make your trend line, something right around here makes sense, and that's what you get. So remember, I would recommend you getting your points and then printing out that scatter plot and then making your own trend line and finding your answers. Now, the answer that shows up in the top is not necessarily, it's almost definitely not the answer that you're going to get when you do the work. Really, what you want is you want to make sure that your answer is close to that. If your answer is close to that, it means you're doing it correctly, which is why all of these answers are estimates. They're all estimates. It's the estimate based on how you did your trend line, based on which points you chose to work with. So now when I'm looking at this particular trend line that was provided for us, I think that the points that are closest to the trend line are this 310 and 290. So the 310 one is 154, 310. The 291 is 143, 290. So I write down the coordinates and then I find the slope of that. So the slope, and obviously based on that chart that you see, the slope should be somewhere around 2. So 310 minus 290 gives me 20. 154 minus 143 gives me 11. So I get 20 over 11, which is about 1.8. But for the sake of this, instead of 1.8, I'm okay if you write 2. You could write 2, you could write 1.8. Since even on my calculator, I got 1.81. If you just write one, we'll keep it at 1.8. So y equals 1.8x plus b is the equation. So right now, that means that the amount of bags that you have is 1.8 times the number of passengers plus some random number. Let's figure out what that random number is. The way that you do that now is that we're going to plug in something. We're going to plug in an x and y value. So let's do 92 for x. So 1.8 times 92. And let's do, the coordinates associated with it, 180. So we just went from slope-intercept form, and now we're plugging in a random, not a random, really just one of the coordinates for x and y, and now we start solving. So 1.8 times 92 is 165.6. So when we do that, so 180 minus 165.6, we get 14.4 equals B. 14.4 equals B. So ultimately the equation is y equals 1.8x plus 14.4. Now, is that close to the equation that we see on the chart? It is very close. 1.8 and 1.98 are pretty close to each other. 14.4 and basically 8 are very close to each other. So this is fine. This is just that's the equation based on the trend line that they made. You might make a different trend line. You might pick different coordinates. So you might get a different slope. As these are all estimates, so it's close. There's also a couple things to think about. If there's 0 passengers, are there going to be 14.4 suitcases? No, there's probably going to be 0 suitcases. This is just a trend line though. So where the trend line is going, theoretically, it would end on the y-axis at 14.4. So sometimes you have to kind of throw common sense and logic out the window and just use the numbers that you're working with. So the next question is estimate the number of suitcases on a flight carrying 250 people. So now you plug in 250 for x. So 1.8 times 250 minus 14.4, we get about 440 people. And the answer here, the estimate is about 500 people. So as long as you showed me which points you're working with, if you put it in slope-intercept or point-slope form and you get close to the answer, you're correct.